In this video, we are going to discuss surface tension on the basis of molecular theory. Now, take a container. In this container, some liquid is there. Any liquid. For simplicity, consider as a water, but you can take any other liquid. Whatever the liquid you wish, you can take here. So, there are the large number of water molecules, liquid molecules. Here I am going to use water, so now I will talk water molecule. So this container is having large number of water molecules. But to make you understand, I am going to consider only 4 molecules. Let us assume only 4 molecules are present. But the reality, the crores and crores of molecules are present inside this liquid. Call these 4 molecules as a molecule A, molecule B, molecule C and molecule D. Above this water, there is the air and there are the large number of air molecules are present. Here, the large number of air molecules are present above the container. In container already having water. So we can say above water, there are the large number of air molecules. Even they are in the large value. They are present above the container. All these red spot I am drawing here, they are all standing for air molecules. Now, here there are the 4 molecules A, B, C, D. They are the molecule of the same substance. There is attraction between the molecules A and B, attraction between A and D. So this attraction between the molecules of same substance is an example of cohesive force. So the force of attraction between molecules of same substance is called as a cohesive force. But there is also attraction between the liquid molecules and air molecules. These air molecules are present above the container. So there is attraction between liquid molecules and air molecules. Liquid molecules and air molecules are different substances. So the force of attraction between the molecules of different substances is nothing but called as an adhesive force. So there is an adhesive force between the liquid molecules and air molecules. So the molecular theory is totally based upon these 2 types of forces. One is the cohesive force, another is the adhesive force. There are the 2 layers here. One is the XY, the layer XY. Here I have shown by the line XY. And another layer is X dash and Y dash. So these are the 2 layers. The layer XY is nothing but free surface of the liquid. And X dash, Y dash is the next layer, parallel layer to XY. So why we are talking about these 2 layers? We are talking these 2 layers such that they are one after another. They are the immediately next layer. And the distance between 2 layers. This is the distance between the 2 layers. This distance between the 2 layers is nothing but equal to range of molecular force. So the distance between layer XY and X dash, Y dash, that is equals to range of molecular force. That means this spherical surface we have drawn, that is nothing but sphere of influence. So the layers XY and X dash, Y dash, nothing but within the sphere of influence. And so this section of 2 layers is nothing but surface film of the liquid. So this section of the two layers is nothing but surface film of the liquid. Now, where the molecule A is present, molecule A present is very much deep into the liquid. Molecule D also present very much deep into the liquid. Whereas the molecule B and C are not deep into the liquid. Molecule B is within the surface film. You see, this is a molecule B. It is within the surface film, whereas the molecule C is resting on the surface film. So position of B and C are not same. Molecule B is within the surface film and molecule C is on the surface film. So the story of molecule B and C is different. Molecule B is within the surface film, whereas the molecule C is resting on the surface film. Molecules A and D are very much inside the liquid. Here is a molecule A. In molecule A, we have shown here the arrow mark. What this arrow mark stand for? This arrow mark stand for a force is acting in this direction, and let us call it force as a F1, and another arrow mark like this. So let us call it as a F2. And similarly, the other arrow mark like upward, call it as a F3, and downward, call it as a F4. So they are even the forces acting in the upward direction as well as downward direction. It is a three-dimensional object. It is a spherical body. So from all direction, the forces are acting on this molecule A. Let us call it as a F5 and F6, and so on. We can draw so many arrow marks inside this molecule. Now here F1 and F2, so F1 equals to F2, so they cancel each other. So along horizontal direction, no force acting on the molecule A. Similarly, F3 is equals to F4. Even in this case, the F3 equals to F4, so no vertical force and not the downward force. Similarly, F5 equals to F6. So even they are equal, therefore no any other inclined force acting on the molecule. Summary is that from all direction, the forces acting on the molecule A is 0. So resultant force acting on molecule A is equals to 0. This is the molecule A. Therefore, the molecule is under stable condition. It is under balance condition. Whenever a body acted upon by 0 force, we say the body is under balance condition. So the molecule A is under balanced condition because the forces acting on the molecule A from all directions, they cancel each other, and resultant force acting on the molecule A equals to 0. So molecule A under stable conditions as well as we can say balanced condition. Even the same story with the molecule D, because it is a deep inside the liquid. Therefore, even the molecule D is under stable condition, or we can say under balanced condition. Now let us talk about molecule B. In molecule B, we have drawn arrow marks, but here upward arrow mark is a smaller in length and downward arrow mark is a larger in the length. What does it signify? It signifies that, as I already told you, there are the large number of air molecules are present above the molecule B, and downward there is a liquid. So the molecule B is attracted in the downward direction due to cohesive forces, and it is attracted in the upward direction by adhesive forces. So the two types of forces are acting on the molecule B. One is the adhesive force, another is a cohesive force. So large number of molecules exerting cohesive force on the molecule B, and large number of adhesive force also exerting force on the molecule B. But compared to the air molecules, the liquid molecules are large in number. Their number is greater than air molecules. Air molecules are not as close as the liquid molecules. So the force acting in the downward direction, that is a cohesive force acting in the downward direction, is larger. Let us call it as a FC, cohesive force, and upward direction, adhesive force, let us call it FA. So on molecule B, the cohesive forces are stronger compared to adhesive forces, and because of this, the molecule B acted in the downward direction. It is pulled inside. It is attracted by other liquid molecules towards inside the liquid. So molecule B is not under balanced condition. It is unbalanced. Whenever the forces in two directions are not equal, suppose I got a body in this direction, F1 equals to 10 Newton, and in this direction F2 equals to 5 Newton, then we say body is under balance and body is under unbalanced condition, because both the direction the forces are not equal. Similarly, on molecule B, upward forces are not equal to downward forces. So the molecule B is unbalanced condition. It is pulled inside the liquid. Therefore, the molecule B tends to move inside the liquid. Now, what about molecule C? You see, molecule C is resting on the surface film, and there are the large number of air molecules also present above the molecule C, and it is attracted in the downward direction by the cohesive forces, in upward direction by adhesive forces. But the forces acting on the molecule C in the upward direction, that is adhesive forces, let us call it as a FA, and downward direction cohesive forces, call it as a FC. The number of air molecules above molecule C are less compared to the number of liquid molecules. So in case of molecule C, even the same story, the cohesive forces are stronger compared to adhesive forces. Therefore, the molecule B is unbalanced. Why it is unbalanced? Because downward forces are larger than upward forces. Therefore, molecule C also under unbalanced condition. It is also pulled inward. It is pulled inside the liquid. What is the reason? Because it is unbalanced, because of cohesive forces are stronger than adhesive forces. So summary is that molecule A and D having net resultant force equals to 0, but molecule B is unbalanced and pulled inside the liquid, as well as the molecule C is also pulled inside the liquid. Now, this container is not rectangular actually. It is round shape like this, or it is a box. It is not just a two-dimensional object, it is a three-dimensional object. It is like a box, and below this box there is a water, liquid. Now, and here are the molecules. Here are the molecules present all over the molecules. and here also molecules on the surface. This is a surface film. I have drawn all these molecules on the surface film. So the molecules touching the walls of the container. So these are the molecules touching walls of the container. These molecules I am drawing here, they are touching walls of the container. They are acted upon by two types of forces. One is a downward forces due to the liquid, that is the cohesive forces, and they are also attracted by the walls of the container. So the molecule I have drawn here with shading, they are acted upon by two types of forces. One is the forces due to the liquid molecules and forces due to the material from which this container is made. Container is made either by glass or some other material. So they are attracted by the molecules of that material. So they are not easily go down. They are not going down because they are not pulled out easily by the liquid molecules. Now there are some other molecules, like this molecule is little closer to these molecules touching the walls of the container. Even this molecule is little closer to molecules touching the walls of the container. So even this one touching the walls of the container. Like this, there are the two groups. One group of molecule touching exactly walls of the container, and other group of molecules which are touching those molecules which are already touching the walls of the container. So which molecules will go down due to unbalanced forces? So which molecules will go down? Those molecules will go down first which are most unbalanced. So this molecule is most unbalanced, this molecule is most unbalanced, this molecule is most unbalanced. Like this, there are the so many molecules are unbalanced. So those molecules first will go down due to the cohesive forces, due to the unbalanced downward cohesive forces. So these molecules will go down, go into the liquid. As soon as some molecules come down, some molecules come into the liquid, they are pulled by cohesive forces. The other remaining molecule on the surface film, they attract each other by coming closer to each other. So these all molecules which remained on the surface, which could not come into the liquid, they attract each other. So all molecules are attracting each other. And when they are attracting each other, what will happen? The surface film will shrink. It will try to become small. It will try to become small in size. For simplicity, I have drawn here molecules in a straight line. So these molecules are trying to come closer to each other. Why they are trying to come closer to each other? Because there were some other molecules present and those molecules already gone into the liquid. So gap is produced. To fill up that gap, what they are doing? They are coming closer to each other. They are trying to bridge themselves. They are trying to come closer to each other to fill up the gap which is developed due to the molecules gone into the liquid. And this causes the surface film to shrink. It is acting like a spring. It is acting like a rubber band. It is acting like a elastic membrane which trying itself to reduce in the surface area, trying to become small in length by coming closer to each other. Suppose from that liquid we now consider the few molecules. Suppose these are the few molecules, and these molecules are attracting each other to cause the shrinking. Suppose these two molecules are attracting each other, these two, these two, these two, and these two. So now we draw a line perpendicular to the line of attraction, perpendicular to lines of attraction due to all molecules. So I have drawn a line here making 90 degree with the attraction line of all molecules. Here we have drawn the line. This line is imaginary line. It is not really existing on the liquid surface. We are drawing for our purpose to understand surface tension. This line exactly not seen on the liquid surface. So on the basis of this concept, on the basis of this idea, we can define surface tension. The force per unit length acting perpendicular to an imaginary line drawn on the free surface of the liquid is called as a surface tension. Surface tension is denoted by capital T. Usually it is a capital T. So capital T equals to F upon L. So force per unit length, that is nothing but surface tension. As we discussed that due to the cohesive forces, some molecules are going inside the liquid. Like this, these molecules are going inside. If the same situation continues, so many molecules will go inside and ultimately nothing will remain on the surface of the film. Actually, this doesn't happen. All molecules cannot go inside the liquid. Surface area of the liquid cannot decrease beyond a limit. To maintain this surface area not to decrease beyond a limit, some molecules must be brought from inside to outside. This keep on going. Okay, this keep on going. In Hindi we say, tu aaya, mai gaya, tu aaya. So that happens. When the some molecules are already going inside, some other molecules are ready to maintain the stability of the surface. So they must be brought from inside to surface of the liquid. So we are bringing the molecule from inside of the liquid to the top surface. So molecules are not easily coming up. To bring them from inside to the top surface of the liquid, some work has to be done. So this work done to bring the molecules from inside to the top surface of the liquid, some work is done. This work done is stored in form of potential energy in the surface film. So here in the surface film, what happened? That potential energy is stored. This work done is stored in film in form of potential energy. The value of the work done depends upon the two factors. One is the surface tension of the liquid and the second one, change in the surface area. Therefore, dW is nothing but product of surface tension and change in the surface area. And work done is stored in the form of potential energy, and this potential energy is nothing but called as a surface energy. Define surface energy. The potential energy per unit area of the liquid surface under isothermal conditions implies what? During the experiment, During this calculation, you are not allowed to change the temperature of the liquid. If the temperature of the liquid is changing, then surface tension is also changing. So, definition of surface energy, once again, the potential energy per unit area of liquid surface under isothermal conditions is called surface energy per unit area. Since work done is given by surface tension multiplied by change in surface area, therefore T equals to dW upon dA implies surface tension is nothing but equals to surface energy per unit area. Friends, in this video, I tried maximum to give presentation in form of a lecture. In my some other videos, I also show the physics concept by using animations. Which part do you like the most? The animated parts or the explanatory parts? Let me know through your comments in comment box. That's all in this video. Meet you again with next topic. Till then, wish you good luck, all the best. Before saying goodbye to you, I would like to request you, please like, share and subscribe the channel. Meet you again with next topic. Till then, wish you good luck, all the best.